So, hello, thank you for joining the lecture, the last one this year, right? And the last one in this course, actually. So, of course, we did not cover all of the topics that we could cover for the the deep learning and AI and all of the use cases for businesses and so on. What I can tell you is that if you keep following the contents of this, like what I'm posting here on the YouTube and also in the other channel AI Ranch, you will probably get many more examples, which would be very useful for basically daily tasks and so on. Just a second before we start. So, so I highly recommend you to keep following the lectures, contents, and interviews with business people here in the AI Ranch. Basically, and remember also that we will have the exam in paper, ABCD test, based on all of the information that we have in the lectures, without additional materials. And this will be held in different locations. We have the schedules for the exams in the Moodle, and the exams will happen alongside with the mathematical exams. It's just that I will give you simpler questionnaires, basically. So, but today I want to focus on a couple of things which we have not yet talking about, which I think are still very important actually, in the especially in the business cases and also in general for you to know about the AI at all. So the one thing which I want to talk about today is the reinforcement learning, latviešu valodā stimulētā mašīnmācīšanās, and the other types of learning. So what the types of learning what we know already. So the most common learning type, which is used in 99%, is supervised learning, jeb pāraudzītā mašīnmācīšanās, supervised learning. Okay, and this is I would say, let's say 90% of business use cases nowadays, because of the Gen AI models. Because of the Gen AI models, we get also zero shot type of learning, but it also is trained actually. In main part, the language models are also trained in supervised learning and also with the reinforcement learning. So this is the 90% of the business use cases, and how it works is we have the labels. Basically, we know in our data that we have carrots, tomatoes, peppers. We have our images with labeled data. All of this comes from your business critical data. Then you train model. We talked about how to training the models in neural network lectures and so on. Then we are applying this model in a real production life scenario. And we are getting, for the unknown samples, for example, we have some kind of machine that sorts bad carrots from good carrots, right? We have data set of good carrots, bad carrots, good carrots, bad carrots. And then we show carrot and the model says this is a good carrot or bad carrot, for example. This is the supervised learning, and this is not only images, it is also text, it is also audio, it is also video, it is also sensor readings, temperature, humidity, any kind of sensors and so on. So this is number one, the very important way how to train all of your models. 90% of business use cases nowadays, I would say. Then there is an unsupervised learning. This looks like this. So this is an completely different way, and this is called unsupervised learning. This has been used in for example, face identification, voice identification, finding similar products, and so on. Like finding similar products, like inside, for example, if I want a movie that I like or something like that. So we have data without labels, no labels. Here we have labels, right? Yeah, somebody worked humanly and added the labels, and the model is able to group together all of the classes, cats, fishes, birds, without any labels. This accuracy is much lower, so this is not something that is often used in the production systems when you have supervised models. If, for example, you are making the some kind of face identification biometric scanner, then you don't have many supervised learning samples for the people that are gonna use it. Like, for example, I do have pictures of people, but I don't have pictures of people that will be my clients, right? So that's why I cannot use it in a supervised learning. So this is a separate model. And this works primarily on embeddings. And we talked many times about embeddings, and this is something you need to definitely know what it is, embeddings. And you can reduce dimensionality embeddings, use them to group them, cluster them, and so on. So this is number 2. And then the number 3 is reinforcement learning. 3 reinforcement learning, or in Latvian stimulētā mašīnu mācīšanās. This is used in when you have simulation environments, well, basically you can use it in simulation environments, or basically when you want to model human behavior, for example, and things which are not possible to just model by using the labels, right? This is the kind of the most complex way, but also the kind of the most fun way how to train the models. And how this works is it is very kind of human-like way, but actually to train these models it's quite complicated. So you have the observation. You see, you have the model. So this is your model, and the model looks at the world. First, it looks at the world or the environment. And how to look at this is you could look at computer games or any game, for example, or the factory setting when the robot is working in the factory floor with the robot arms, for example, in simulation environment. The robot arms are looking, or in this case, the robot mouse is looking at the walls, and this is the input of the maze. And the robot mouse is then going left or right, for example, or yeah, so basically left or right, that's about it that it can do, right? And every time when it does the movement, it tries to listen for reward, and the reward is this cheese. So, and in the whole maze, there is just one cheese piece. If you add in the maze more cheese pieces, this will be easier task. But in real life scenarios, like for example, the stock trading, which is kind of dubious sample, but many kind of like robotics scenarios, you would not have many rewards. You would just have the one reward. You did good or you did bad, for example, and that's it. And that is actually that reward mechanism which you need to train the model on. So instead of labels, you don't have labels as in this case, but you have some kind of way to generate reward, basically. This can be very easy in computer games, because then you have like, you win the game, you lose the game, right? It is more difficult in other scenarios, but it is sometimes only way how to do things. Like in the robot, like robot arms, so you can move around items in million ways. There is not only one way how you can move around item in a factory floor, like in like a robot arm taking one piece of detail and putting in another place. Actually, just maybe I can share some more examples of that. So, so let me show you some examples. So there's a robot arm in ABB. So there's Latvia also. There's robot arms. So there's one way you can just program these robot arm. Right. I just want to make sure that audio is not on here. Okay. Okay, so let's look at this example. So we have the robot arm writing signing the papers, right? Like this kind of example. But the thing is that the robot arm can hold the pen, like a million ways. The signature, if you want to fake the signature, it will be exactly my signature. But the way how the robot arm moves to make the signature, this is like million ways how I can do this. And but if I have the reward that signature has been faked correctly, then this is 1. If the signature has been faked incorrectly, this will be 0. Oh, I see the question. Exam topics. Yes, I will give the exam question examples in the Moodle. So with ABCD, you need to look at them, learn them, but this will not be all of the examples probably. I will try to make it as close as the traffic driver test, where I give the examples beforehand and you learn them and look like basically look all the answers up and learn what is the real answer, because every year students do not learn the right answers, because often the answer that you think is the right one is not the right one, because the things are much more complicated than people are like telling about ChatGPT, for example. So I will give those topics. I will not give the right answers. You will need to look up them yourselves, and I might add maybe some 1 or 2 questions which are not included in the ones I give you, but most of them will be included. So the exam will be quite straightforward for you, hopefully. So we don't need consultations, because I will give you all of the answers, and if you don't know the right answer for some question, you can write me on email basically. But I please don't write me like I don't know all of the answers. It's I will, so it will not be proper way of learning. Okay, so that's that. So this is that reinforcement learning thing. So if we look at how the all of the AI world exists, there is a good example of which was given by Jan LeCun, one of these masterminds of AI, is that the supervised learning is kind of like this icing on the cake, basically. So it is super important, very tasty on the cake. Then the middle part of the cake is actually the unsupervised learning, because we can pre-train all of our models without labels. Then we add a little bit of labels, the icing, and then the cherry on top is actually the reinforcement learning. So we are having just one short signal of information, and we are able to train the model. So let's go step by step through these examples of what is possible to do with reinforcement learning. So the one of the best ways how to look at reinforcement learning is is through computer games basically. So, and if you go back to different levels of what has been done. So, for example, there was the Deep Blue computer, 1997. It was one of the first attempts to try to use some kind of reinforcement learning type of search models for basically, and this was chess, and this was Garry Kasparov and from Russia, and the from America it was that computer, Deep Blue from IBM, and basically the idea was that it was a chess match between AI and chess grandmaster Garry Kasparov, right? And the Deep Blue was able to win. Basically, it was won the match. So and it was kind of like the first big thing where actually the somebody was able to beat a human player basically, and this was primarily used on very simple models, not the deep learning models but search type of models. And chess is actually a very simple game. Even though you think that chess is difficult game, the chess actually is even though it has like many combinations and so on, you can do with with fast enough computers the search, and there's not actually many inputs, so there's just the positions of the pieces on the board. So but there are much more complex situations that even you might think that are not complex, but they are actually complex. Like for example, modern computer games are like 100 times more complex than chess actually. Even though it's easy for kids to play, it is very difficult for AI to play, for example. So next one, for example, will be IBM Watson. So let me show you that one as well. So there is an English computer English I mean English TV show called Jeopardy. Uh, so let me show you. So this is called Watson Jeopardy, and this was 2011. I think between 1997 and 2011, some other things happened, but basically 2011 was just before a deep learning AI just took off. So, so the Jeopardy is the way how it plays. Let me show you actually video of it. And they made IBM again. IBM was the one who made this. Maybe let's write it also here. So this is IBM. Here also IBM, and this was the first proper kind of like AI model before the deep learning actually was popular. So 2011, this is like this TV show game. Try to make it a little bit larger. And the way how you play this game is that players select cues from various categories, receive answers, and must respond with correct questions phrased properly to earn points. So that basically the players need to guess the question or the answer that is given, and here basically the Watson beat the best players that were like from the human side, and was able always to respond first one. It was, I think it like, let's see what is the last at the end. I think the other people, okay, some they got some questions also. I think at one point they just clicked the button before so that they would be able to answer first. But that was 2011. And again, all of these games, it is easy to train with AI. It's difficult, but it's still easy because you can basically use use the signal that the game is won or lost, or this is correct or wrong, and you don't need much labeled data except the game itself, right? So this is then the Jeopardy. Then the next one. Next game. So the AlphaGo, that was Google already, DeepMind. So AlphaGo 2016. So Go Go game. So this is old Chinese game, 2016 by Google DeepMind. And this is already much more complex game because in this game, even though the rules are simple, you need to, I think it was like corner all of your opponent's pieces so that they cannot move in one corner. But this has been like for centuries a game with strategies, with books written about it. And after the game, when this grand champion lost the game, which he was, I think, really depressed when he lost the game. Actually there were some people who are writing blog posts, blogs, like the strategies. So basically, the AlphaGo was able to discover strategies that was not discovered for thousands of years, basically. And this was done purely by AI. AI outsmarted the human, making strategies that human was not able to invent for thousands of years. So that's also very powerful thing. So let me also put the way how it was trained. It was trained on this simulation environment, of course, but also it was trained on itself. So it was playing against itself of Go. So let me find scores. There were some examples of how it was trained. Let me find. I think I was able to find it. Okay, I think this picture. So it was trained against itself. Okay, load. It's not loading. Okay, good. Right. Good. So that was the Lee. I think was it? There were some human player games, I think, as well. But basically, the original version was the gray, and then it started AlphaGo Fan, Lee, Master, Zero, and Zero was the version which beat the Grandmaster. So that it was playing for 40 days against itself, and every couple of days it got much better. So basically, you have the simulation environment, you have this AI model, and it was able to invent strategies that no human has ever invented. So this is also some very significant feature. You can do this also for the drug discovery, because again, you just got the Nobel Prize in chemistry for AI model that is able to predict the protein folding. Basically, so also in the similar way. Yeah, so to do this manually, this protein folding, it is crazy. It's like 100,000 euros and takes half a year. And you can nowadays do this for free using these AI models. So that's that. Then the next step, the Google DeepMind started building even more advanced models. So there was really fun ways. So this is 2000 what? So 5 years ago. So 2020 basically. So multi-agent reinforcement learning, 2020 Google DeepMind, and these models also really fun. So this is what you can do with these models. Basically, you can give this environment, and it was tasked that those two blue guys need to defend against the red guy, and the model was, so the AI didn't know anything about strategies, what to do in this environment. It just had buttons to press, like go left, right, and just move around items and try to survive. So if the red guy doesn't kill you, then it's a good game. So they discovered that they can block the door. Basically, that was the first thing they discovered, and basically the red agent was not able to win them. So, but Red Agent also learns. Red Agent also learns and try to do some strategy so that he can get to those blue guys. So then the Red Agents learn to use the ramp. So you see, they learn to jump over and attack those guys. So then the blue guys learn to take the ramp inside the room so that the red guys cannot take the ramp. So that was the first task for them to just, because there is a little bit of delay in the game in the very beginning. So this is the way how to win the red guys. And all of what you see here, it is completely learned automatically. Nobody programmed how to do these things. The only way is that there is a signal, you did good, you did bad. Then they also learned how to build shelter, so how to build their own house, for example. And the other guys try to block so that they cannot build a house. And then finally, they even exploited defects in game. So basically, they were able to. The other guys are trying to hide in the shelter, but you see, this one invented that they can skateboard the items on the game. And this was something that was not intended by the researchers. Basically, the AI models were able to discover and do things which humans even did not know was possible to do. So this was also a very powerful development. Then came the next step. The next step, I think it was OpenAI. We'll see. So the next step was Dota 2. So maybe some of you have seen this game. So let me see. So this is also 2020. So let's say what was the name of the model? OpenAI 5. That was before the OpenAI made ChatGPT actually. So this was Dota 2 game 2020 by OpenAI. And this is even more so this is very complicated game basically. So if you look at chess, at Go, so this game is 100 times more complicated than those games. So even though some kids know how to play this game, you need to control many characters on the screen, but this is something like close to the real life. And basically the computer, the AI model sees the same screen as human sees. It has the many limitations, even one limitation that they made so that you cannot click too often, because if you're superhuman AI, you can just click on all of these characters, micromanage them, and win every single time. But even though you can see here in the middle part, so let me see. So the players, the human players, the main grandmasters of this game, they made jokes during the game in the chat. What they do here, so they ask, what is the probability of you winning, right? So they said, we estimate the probability of winning 95%. So, and these guys are just laughing. It's not possible. What you're writing there, it's just a like joke. We're playing so good, right? And then the player does like a small move, and after the moment, the model says, I will win you with 99% accuracy, and then just in a few seconds later, OpenAI comes in with all of their agents and kills everybody basically. So even in super complex strategy games like these, where you have maps, you have weapons, you have hundreds of buttons and so on, the AI can beat human best players. And after the game, when they interviewed these players, they said that they were feeling like they were playing against the pro player, but like an alien, because it was acting like a human, but at the same time being like a superhuman, basically. So this is something that's also possible nowadays already. So this is then the Dota type of computer games where you have full 3D computer games, fully automated, making better scores than any human can do. So then the next one is Alpha Star. Alpha Star, the StarCraft game, also 3D game. So what was that? Again, I think all of these games happened about 5 years ago. This was DeepMind. So Alpha Star, StarCraft, Star. And why these computer games? Because computer games are extremely complicated, but these are environments where I can simulate these games, right? And if I have real life simulations, I actually can also train the models. DeepMind. Okay, so and here again, the grandmasters were beaten by Google DeepMind. Alpha Star was able to beat all of these StarCraft players. So, and to continuing this trend, the next important, I think, the milestone is now moving all of this technology of reinforcement learning and all of these AI models to the real life, basically. And one of the great examples how to do this is, so let me find it. So these self-driving cars, basically. I recently was in America and drove myself the Waymo and Tesla FSD, and these things are actually working great. Like there's no bugs, no problems, basically almost no. Basically they are, I believe, like next year or maybe in like a few years there will be self-driving cars everywhere. Basically there's a little bit of bad press about it, but otherwise it's like you need to go to San Francisco to try to drive without driver. There's already like many cars like that, like the full city of them, and you would then experience this yourself. But the one thing I want to show you is right. So is that what is actually happening here? So the way how Tesla's FSD and Waymo full self-driving cars work. So if you write down, this is the next milestone here. So self-driving, Tesla, FSD, and Waymo. They are basically running full trials 2024. Basically, you can pay as a robot taxi for them. Is that how they work? Is that they are collecting information from their sensors. They are training the virtual environment, so they're training the world model, so how the world behaves, how the people behave, how the cars behave, and so on. And then they can train the reinforcement learning to do the actual driving with all of the things like braking, changing gears, like evading collisions, and all of the things. So that is also really powerful. The other thing which is important is, but it's a little bit complicated to explain, is that the ChatGPT actually is also trained using the reinforcement learning. It would not be possible for you today to speak with ChatGPT if there would not be reinforcement learning available. So, and this is being trained by basically reinforcement learning by human feedback, and this was from 2022. So 2022, and how this works is let me show you. Had some picture about it. Okay, let's just use this picture maybe. So the ChatGPT, originally ChatGPT would generate like a supervised learning. Basically, you would have if you would have like input prompt, and then you would have output, right? So this would be like a normal supervised learning model. But if I do this way, then this is completely wrong, because if I do this way, then I will have really bad language model, because it will always respond in the same way, and even if I add the temperature dropout, so on, it will never be good. So, but how the reinforcement learning is being applied, they have these couple of steps. So first, they use the this labeled dataset with inputs, outputs, and even human is labeling that this output is better than the other output. So they use that, and they train the reward model. So they train the model which is this green one, which is able to get the input and output, the prompt and generated output, and say what score do I get from this output. And then when they train the full large language model, they put the language model here. We talked about the language models. Then they put the reward model, which is this reinforcement learning model. And then when we have the input prompt, it generates 10 different outputs, for example, and chooses the output with the highest reward. And in this way, we can make a really smart model to respond like a human would respond, because it will prefer always the output which human prefers, even though I never ever have any kind of labels in this part. So this part is fully reinforcement learning. The labels are only to train the reward model here. So that's why also even the ChatGPT is a result of reinforcement learning. So these are the great things. The other thing which is also very close to the business and something that you need to keep an eye on is that we have the Gen AI, we have the reinforcement learning for computer games, for virtual environments, and so on. But we also are very close at automating very complex robotic tasks, actually. So let me show you some old ways how these things have been done and how nowadays these should be done. So if you look at the old ways, so if you in any factory nowadays, even to the nowadays, there is these Robot Studio ABB type of robot programming. So you have the robot, you have the computer programmer human, and the robot is then programmed to do exactly the thing that you want, right? Like carefully, like sandpaper things, move things, like change things, replace things, weld, like all of these things. So this is old way basically. So now the thing which is coming to all of us is that you can program all of these robots without the computer programmer. Basically, you can here's Amazon warehouses where basically all of the packages, all of the stacks and everything in the warehouse is done by robots, and the new generation of robots are basically very human-like. You can basically tell them what to do, you can show them what to do, and if the environment changes, you can still be able to execute it. I will give you some more examples. So there are a lot of research from Google, but there is also recently really good examples. So this is just 1 year ago, and nowadays we even have much better robots. So this is you said basically you give the command bring the green star, and the robot navigates the environment, understands the language. It is not programmed. Nobody programmed this robot. This robot learned how to do this themselves using the simulated environment, using the basically reinforcement learning most likely. So, and it can do all sorts of crazy tasks. It can like take out trash. It can, and nobody programmed this, and this would be impossible to program actually. So if you want to program this, it will take forever, because there's a million ways what can happen in the environment, right? So that's one. The other things, just a second. I want to show you more of these robots which are actually coming to the business cases. So So let me show a couple of others. I just saw the Forbes 2023-24 inventions list. Want to find it and give to you. There's I forgot just the name of that. Oh man, this is the wrong link. Okay, I remembered. While I was searching, I remember. Uh, Yeah, so there's a couple of companies already who are making these humanoid robots. So one is Tesla, but one is other one which was working with BMW already. So Figure One. So Figure One is already robot which you can automate to do like many things. And again, you can if you look in the videos for the examples, you just speak with the robot in human language. You show what needs to done, and the robot can do this day and night in factory, and it costs also like not as expensive. You will see in a second some cheaper options, but basically, oh sorry. So the Figure One is one of these robots which is worth to know, and it was in actually in the Forbes 2024 best inventions list. So this is one. Tesla bot is also one other one, and then one I definitely want to show you is something which will become reality very soon. Is Unitary. So you know probably the Boston Dynamics robots, but those Boston Dynamics robots are extremely expensive, right? So they cost like 100,000 plus euros. So the Chinese are building something that's called Unitary. And here you see the price. Basically, you can get robot dogs for 3,000 euros. Basically, if you have this kind of price range, you can imagine what you can do with this. So you can completely automate the security functions. Like you can track if the doors are closed, if there is undisclosed people in the property. You can do the agricultural things. You can do the delivery services. You can do also like even some maintenance services, some dangerous locations to go. So basically, these robots are now going to this price range. So you can imagine what happens if you combine cheap, high performance robots with AI that is based in the large language models, the reinforcement learning and other things. So what you need to keep in mind is that in near future, you will be able to automate human physical tasks, very many of them. So this is a business opportunity also for many things. So that's that, and then I can write here is the next step is just like robotics basically. So there's the Figure One, figure one, the Tesla bot, the Unitary, Boston Dynamics, and so on. So this is coming basically. So this would be, I would say, combined with AI, 2026, maybe 2028. So we will see lots of human physical work fully automated. So that is that. Then let's, if you have any questions so far, type in the. Oh, I see actually. Would need to understand rules of traffic rules that are labeled data. Okay, great for the question. Thanks for the question. Great. So regarding the self-driving cars, yeah, there are different ways how to do this. So let me give you more examples of that. So Tesla FSD, Waymo, and then there is also Comma One, I think it was called. So the Tesla FSD and Waymo do this. They have actually this reinforcement learning plus the layer in between where they can program things. But this is not the only way. So sometimes you can learn all of the traffic rules, even so right. This is not the one, Comma One, self-driving, because like I think it was with 2M. Yep, 2M, sorry. So there is one notable thing. So example, Comma One. So they are building open source self-driving systems which are fully trained without any human rules in between. And they're actually, when you look at examples how they are working, they are achieving great results with very little hardware. Basically, this is a phone plugged in the car, and it is learning basically the rules like traffic lights, the stop signs, and everything without the somebody programming the rules inside. So if the rules changes, of course, that is might be a problem, but but it is possible to train. Basically, it's not like it's impossible. So if the rules changes, maybe they can just change the training data. But you're right that Tesla and Waymo, they actually, when they have all these environments, they have this layer where they also include some human rules as well. But it is not the only way how to do this. Okay, so that's that. Then the next step, which I want to talk about, is so we talked about reinforcement learning, robotics. The next one is regulations. So let me try to find some of a slide about regulations. Just a second. Just a second. So I will find. I have actually prepared some presentations where I talk about EU regulations. Let me find some of those. Where was it? Just a second. I lost it somewhere. Just a second. Okay, I found it something. Okay, great. By the way, I can show you some videos in this presentation. I had it. So I myself was driving also the Waymo. So the Waymo here is the fully self-driving car in San Francisco. So nobody is sitting at the driver's seat, and it's actually very aggressive when you start driving. It just goes to 50 very fast, and it was able to evade all the people on the streets, everything. And we even met that the pensioners are preferring to retired people are preferring to drive this rather than human drivers, because they think that this is much more reliable actually. And also the Tesla FSD full self-driving car was in Denver. So basically I just put in the map some location where I need to go, and I don't touch. I need to just hold a little bit the steering wheel, but it drove me from address A to address B through all of the intersections, all of the many highways to the right address. Basically, I don't need to even think where to drive with this car. So it is working great, basically without any problems. So and the regulations. So there are a couple of regulations. Oh, sorry, this is in Latvian. Okay, so but let me explain. So the GDPR law, I can actually do quickly some translations, and that's also a little bit of demo how to do things. So GDPR law, this is the data processing, the very important law to abide for business purposes of AI. So the thing is that you always have a data controller and data processor, basically. So the data controller are you, the business owner, with all of your data. You are the main person. And data processor is the partner who is working with giving you the AI solutions, for example. And then you have like tons of different rules and regulations what you can and what you cannot do with private data. And as you see that Europe has like tons of rules, and the Americans have almost no rules basically. And they are actually in the AI, they are like 10 times, even maybe more advanced than Europeans, because Europeans are very restricted. And even if you do something wrong, you can basically get very large penalties, like 5% of the turnover. So there was a case when TED got the penalty, huge penalty, just for basically not deleting user data when the person ended their subscription service, and then half a year later this person got the bill for the subscription service even though they ended. So maybe there's a good things that you kind of protect the customers. From the other side, these kind of rules make that all of the lawyers and companies are super scared, and they just prefer often not to automate anything, not to do any kind of AI solutions, because it will take like maybe 6 to 12 months just to produce all of the papers, so in the large company you can deploy any kind of AI solution. The one thing very important is that for the ChatGPT and large language models, it is not allowed to send private data to OpenAI, to ChatGPT. The only way how to do this is actually you need to buy Azure private instances, basically, and you can do that also in Latvia. And then the Microsoft takes the responsibility of data processor. So this is called Azure private basically ChatGPT or GPT instances. And that is something that is allowed basically. And if it's deployed on EU, and this is more expensive than ChatGPT basically, but you need the programmers there. Somebody needs to connect all of this. But otherwise, if you're copying and pasting in private data, basically somebody could give you this kind of penalty. So this is something to keep in mind. So imagine some of your customer finds out that you copy data in ChatGPT, you might get a penalty. So that's something to in mind. Then there is also AI regulation, which is coming on to us very soon. Let me quickly do translation on. I forgot that this one was in the Latvian. So this is EU AI law, and there is the prohibited risk, so risk which is not allowed at all. They're classified in this way. These AI solutions, basically unacceptable risk. There is a high risk solutions. There is the limited risk solutions, and there is a minimal risk solutions. Yeah. So all of this is based on for the business cases, right? So the unacceptable risk solutions are prohibited. Basically, you're not allowed to do anything of that, but it is completely allowed in research and police, basically. So, and the things which are prohibited, and which some of them are really tricky. So any AI system which is subjective, manipulative, deceptive, fraudulent, discriminatory. So already you see, like, what about the, like, let's say fact checking for news? Somebody might say this is manipulative, right, or deceptive, and they could just sue some news corporation or something, like for using some tool for evaluating news or something. So it is really slippery slope. There is a very vague description that can be used to attack companies, basically. So also biometric categorization, facial recognition, social points, and emotion tracking. And emotion tracking again, and the biometric things. These are like many people have these cameras, for example, for recognizing if there is somebody like coming to your home that is allowed to be there. And this is already in the market for many years. Now in the EU it is not allowed anymore. So everybody needs to basically destroy their cameras because it is unacceptable risk. Or emotion tracking has been used in many cases. Like right now, I have been just in the AHA center in Estonia, and they have emotion tracking in the front desk where people, just for entertainment, right? But this is again prohibited under new regulation. The new regulation is not yet come into the power. Many countries are fighting against it, and I think it's a reasonable fight, because if all of this will come into full force in all of the countries, then we will lag behind with AI even more than we already do lag with America. So the high risk is also extremely problematic. The prohibited use cases is one thing, but high risk is something that is being used in all of the business cases. Like, for example, biometrics, critical infrastructure, education, all of the AI models related to employment, health, law enforcement, public services, democratic processes. So this broad definition makes that there will be a huge paperwork, like the same amount of paperwork as for GDPR, so that anyone wants to use this in business, they will need to what to do. So they will need to register in EU database. All of the solutions must be then registered. So that's step number one. Step number two, there must be a documentation of basically that this model is not discriminatory. There is what kind of data has been used. So if you are a business owner, you're not happy about this, not because you want to make that your model is bad, but you don't want to generate like tons of papers just because somebody thought that this is a good idea. And also you need to notify user that you are using AI systems in your business, and maybe somebody will not be happy about that. So then the limited risk, which is also funny, because I would put many of these as a high risk, and what they said as a high risk as a limited risk, basically. So all the chatbots, generated content, even deep fakes, recommendation systems, they're all really limited risks. Basically, you just need to have transparency. You don't need to provide you don't need to provide lots of documentation if you want to use deep fakes, but you need to basically notify user, basically user notification. And by the way, the AI solutions for deepfakes generated content, it is almost impossible to detect them in real life. So no AI systems for detection of generated content work really, really bad. So that's something to basically that is on the provider itself. And all of the other solutions would be with the minimal risk, and they are permitted, basically. So let me copy these slides also back into the Canva. So in short, just for you to know, as a business people, is that you can use all sorts of AI solutions. You need to abide by GDPR law, which makes it so that you need a ton of documentation. The actual providers for AI solutions, they usually, companies have lawyers that produce this documentation. So if, for example, you come to some of my solutions, then I have some lawyers that create a lot of documentation how to deal with all of these things. And I remember about also ChatGPT, because that's also a problem. Then the AI law, this is something that is not yet enforced in all of the countries. Some countries are just now thinking how to actually implement this law, and I see lots of pushback against this law, because this law is really bad for Europe. And basically, this is something to keep in mind, that all of the high risk, limited risk, minimal risk solutions can be used. It's just that, again, you will need to have lawyers with the tons of documentations, basically. Yeah, so just about this thing, it's you see that there's a lot of solutions which are not available in Europe. For example, Apple Intelligence, they're saying that they're working with the EU so that by the summer, Apple Intelligence will be available in iPhones. But up till this time, Americans can use it, and Europeans basically are not using it and not able to use it. And there all of the solutions like Meta is building lots of cool AI models, which are now the latest ones will not be deployed in Europe at all. You need VPN to use them because they don't want to have problems with all of the things which I showed you. So basically, these regulations are really problems for all of us. But yeah, the one thing which we're doing is the MILA, Artificial Intelligence of Latvia Association, and we're trying to open eyes to politicians to see that we don't want to become like second grade economy because of all of the regulations of AI. So but that's something to keep in mind. Okay, so that's that. So this is the regulation. What else? We have the last piece is the human capital and the hardware resources necessary. So human resources, let me find, do I have some notes about these things? Okay, so the human resources for the AI solutions. As I showed you about all of these regulations, you definitely, like it's not really easy to just take one full stack developer, programmer, and just implement something on yourself. There's a lot of problems with these things. So I would say that normally what you need to make sure that if you want to build in your company yourself some AI solution, you need some kind of experienced AI data scientists. And basically these can cost quite significant. So even starting from a couple of thousand euros per month, basically. So, and experienced AI data scientists, you need a software programmer. Then you need lots of data labelers. Basically, these are people who are not programmers, but people who will maybe the experts of specific trade, basically experts of process, basically. And these human labelers will probably, yeah, this is actually called like that, labelers. They will need to produce. So for simple solutions, it will be maybe 10K samples. Maybe you will need 100K samples to make high quality solution. For example, you want to detect in factory defects, you need at least 10K defects labeled, or maybe even 100K defects if you want to have 99% accuracy. So that's something to keep in mind. Then you also need basically lawyer or the basically the data protection specialist, and of course the project managers and so on. But these are kind of these specialists which are sometimes you even don't think about them. Maybe often people just think you need the software programmer and you can make AI solutions, but actually you need a data scientist, which is actually mathematician, not a programmer, and the type of mathematician who understands these things: software programmer, data labelers, and lawyer. And then from the hardware, so normally for any project, just for you to know in the budget, right? So let's say average Baltics project, right? So it would cost around starting from 15K euro a month, basically. So this is how much it costs if you want to build your own AI solutions, basically. But it's sometimes you can build some full solution, and so full solution can be done in sometimes not shorter than 2 months, I believe, but maybe 2 to 12 months, basically. And imagine if the process can be automated, maybe 30K it is not that bad. So that's one. But then also there is the hardware resources. Hardware resources. And from hardware resources, you need two things. You need first the training resources, and you need the deployment resources, production resources. Training, it is extremely expensive. Basically, for training, you often need something along lines NVIDIA H100 GPU, which costs about 20K a piece, basically, and you often need many of these just to train the models. And for the production, you sometimes can go with RTX 4090 with 24 gigabytes, which costs around 3K plus the computer itself, the server. In total, it might be, let's say, so the total might be 15K here, and the other one total might be about like 30K. So, and what you can do, either you can rent the hardware. If you want to rent the hardware, the best place for renting the hardware is actually Vast AI. So if you want to train the model on NVIDIA, I mean on the AWS, Amazon services and so on, it is extremely expensive. So Vast AI is the cheapest way. But the safest way, like AWS, Azure, OCE, so these would be the safest way because the data would be then safe. So if you have working with the sensitive data, then probably cannot use the cheapest way. But the difference is about like sometimes even 5 times, maybe even 10 times cheaper. So you can imagine how much all of this costs. So, but still, like you don't need always to automate everything. You need to decide if your business process is worth automating, and keep in mind that many things are already done. So remember this site, there's an AI for that, and there's many sites like this where basically you have ready-made solutions or let's say Microsoft Copilot solutions or some other solutions which are already done. So if you can find something which is already made for you, then it might cost maybe 500 a month, or just like the average of these solutions, how much it costs for business process. I would say like 50 to 500 euro per month. That is kind of like the pricing range for automating some business solutions which are already done. So this will give you a little bit of what to expect, what to find, and definitely not recommend to build some things in-house like for yourself immediately out of the box. Like you need to work with some partners. You can find some partners in our association page as well. So Mila.lv, there's a lot of AI like kind of partners in Latvia and the Baltics that can help you out. And either find already done solution, and then when you understand how everything works, then you can hire your own data people. Okay, so I think that's it for this couple of intro lectures that we did. Again, I will post the exam questions in the person to do the exam on paper, so you understand all this. And we are happy. And if you're interested more in these topics, as I showed you in the very beginning, definitely follow the AI Ranch. There's actually, I think, like 20 plus interviews with businessmen who are deployed, who have deployed AI solutions in their business. So That's about it for today. Bye bye.